My name is Daniel Mesco, and this is my benzene molecule program. So I guess I'll start at the top. At the top we have just my imports. I imported the java.awt class. I did all of it, but I'm only going to use the graphics anyway, but for safety I brought all of it, and the applet so that I can print out in the applet. And then in my public class I just defined some variables and some fonts that don't come into play until at the end, towards the end of the code, but I wanted to make sure I got them out of the way when I remembered them. So I just, at the end it's going to say benzene, and it's going to say, the black atoms are carbon, the gray are hydrogen, and then since there's a special rule with benzene, I wrote that in as well to clarify. And then I created two different types of fonts for the variables, which I'll show you once I run it. Should I run it first maybe, or should I
run it? Let's take a look at it and then go back to the code and explain what you did.
Okay, I'll do that. I'll erase these. There we go.
Little lag.
Yeah, a little bit. Compile and then run. So there it is.
Very nice. Very nice. Looks very nice.
Thank you. That's benzene. And then at the bottom here I have written that the black atoms are carbon, the gray atoms are hydrogen, and that all the bonds between these black carbon atoms are delocated electron bonds, which benzene's a special case because the bond lengths are not long enough to be double bonds, but not short enough to be single bonds. So they call them, the electrons are called delocated because they don't specifically share or not share. They go for either atom, so they call them delocated electron bonds.
FYI, folks, benzene plays a crucial role in radiocarbon dating. The amount of beta particles that benzene gives off in a machine called a liquid scintillating analyzer is proportional to the age of whatever it is that you are trying to date. So the more, it's inversely proportional, which means that the more beta particles the benzene gives off, the newer, the more recent the age of.
So back to the code then. I'll show you how it how I did that, and I'll move this along to the side here so that I can keep it there. So I started right off with the paint, the paint void. And I define all of it at the beginning, but as it goes down, a lot of it's repeated just with different parameters, so I didn't really define it in comments here. But I set the first color to gray because I went in a counterclockwise motion, so I started with this circle up here first. So I set the color to gray. There's the preset color in the applet, and then I filled an oval at these dimensions. So I found a dimension that was sort of centered in my applet to make sure that I had enough space for the whole atom. And then I set the color to black, and I did a line, which is this line here, in black. So here, that's what.
Explain the four parameters there for draw line.
For draw line, the first parameter is an x coordinate, and the second is a y, and the third is a different x coordinate, a different y coordinate, so that you can show the first point of the line and the second point of the line, and then it'll connect those 2 points. So 220 and 55 is the top point. So you go over you go over 220 and down 55 at the top. Well, you can understand. And then the next one is also 220 on the x because it's a vertical line, but it's 80, so it's down 30 pixels from the original point here down to here. So that's what the two parameters there mean. Now with fill oval, the parameters are a little different. The first one is an x there, and the second one is the y, but the x starts on the corner here, and the y is up there. And then the 40 and the 40 are the minor and major axis dimensions. So technically it's an oval, but since I made those lengths the same number of pixels, it makes a circle. There's no fill circle function. So if I had made this 40-50, you would have seen an oval that stretches longer. So that's why it's a circle, because they're the same dimensions. So
yeah, makes sense.
So that's the oval function and the line function. Then I did it again here with the first black circle. So I filled the oval there. And now this line is the first line that's not straight. So with these lines it was very difficult because you had to find the right way of curving it. So I did this atom here and then this line here. And finding the right, sometimes you want to start from the center of the circle and then go to not the center of the circle. So the whole process is trial and error because you see what it is and you see, oh, I went over too far, or I went left too far, whatnot, because it's hard to get a visual of what you're graphing until you see it graphed.
Right.
So, or you see it, printed out. So then I did that again all the way down, and I labeled this the second black oval, which would be right here, and the second gray, and the third all the way down, and the colors change, gray, black. All the ovals are circles, so they're all the same, but the dimensions are changed on the lines, especially for these curved ones here. These were difficult because on a lot of them you'll see that the line starts in the center point of the circle, which is easy because I knew I just had to go down 20, which is half of the 40 radius of this, or the 40 diameter. But for these, I didn't start at the center point of the circle because that would have been down here. So I had to fiddle around with it, extend the lengths to make sure there were no empty spaces. But after a lot of testing it out, I was able to make it work. So it looks like a short segment of code here in the paint void, but it took a while to figure out.
Actually make it compile properly.
Yeah, exactly, because there were lots of little, line issues. Not necessarily that there was a problem in the syntax, everything was written properly, but the lines were in the wrong place, and it wasn't representing a benzene atom.
Right.
And then at the end is where I call in the variables that I defined at the top and the fonts. So this is the last gray oval at the top right, and then I start with the word benzene. So I establish the color as red because I wanted it to be standing out from the rest. I set the font to big, which actually now that it's important, I'll go back up to the fonts so we can look at what I used for those. I created two fonts, one for the name benzene and the other one's for the little extra notes. Font big is just big is the name I used to help me, big and small to help define one and the other. And I used Arial for both of them because it was a pretty standard text. 0 means that I'm not using italics, I'm not using bold, I'm not using any special things. So it's just plain text. And then the 15 and the 20 is the size. So I made big a larger size than the small. And the sizes are relatively similar to what you would see in Microsoft Word, like a 12 point or a 15 or 20. So I use some pretty big sizes for the name benzene, and then the little small notes on the bottom I used the small one. So I set the color to red here, which I can now use my red pen, and I set the font to big, and then I said to draw the string benzene, and the string benzene says benzene, and I put these parameters just by typing in numbers that seemed closer to the center of where I started, and then I messed with them just by a couple of pixels to find out where it lined up pretty evenly with the atom. And then I created black for the rest of the words, for the names, for the description of the bonds and the atoms, and makeup and makeup 2. Those are makeup and makeup 2 are the ones that say that the black atoms are carbon and the gray are hydrogen. So makeup is black atoms carbon, makeup 2 gray atoms hydrogen, and then carbon bonds is the delocated electron bonds. So you go back down, and I set the font there to small so that it could be, because it was a long sentence, and I tried using a big font, but it was too large for the applet. So I made it smaller, and then I printed that out below. And each one is there's 5 pixels below the last one. So on the Y value. So then you go back to the applet and you can see how it looks. There's the benzene in red, and the carbon and the hydrogen bond descriptions, what I call makeup. And then there's the last line there about the delocated bond.
Looks very good, Daniel.
Thank you.
Question about your code. I noticed there's a lot of methods from the graphics that's constantly being used over and over again. Is it possible for you to create a method that would actually do a lot of what you're kind of repeating over and over again? Is it possible for you, for example, to create a method called hydrogen that has certain parameters where it'll actually draw a hydrogen atom in a certain location in your app?
Oh, I see. So I won't have to keep defining the parameters every time. I could just,
exactly.
I could just call upon it. That I think I might actually be able to do that. When I was
I mean,
thinking
at this point, obviously, I wasn't looking for that at this point.
Yeah, sure.
But something for you to consider in the future when we get into methods in Java, how they can automate a lot of things that is now repetitive in code.
Yeah. I could call upon a hydrogen method, and I wouldn't have to write fill oval of a 40 and 40.
It would
radius.
automatically,
It
you
would
just call upon hydrogen,
Yeah,
and it
put where
automatically
goes.
create an oval that's gray, and with the other parameters that you put in the method, it'll actually put it in the upper left or the upper right or at the bottom of with your molecule or whatever.
Yeah. I was just making sure I went step by step to make sure everything was in line.
Oh, of
first.
course,
Yeah,
of course.
That's definitely something.
Questions, comments?
I have a
Foster?
comment. I mean, even before you wanted to create a method for each individual shape,
Right.
to make your code a little bit simpler, you could also, for the when you set the color, the program actually just retains that color throughout the program. So if you just shift a few of them around, you could actually just save a bunch of lines of code by writing like,
Yeah,
you know,
you're right. I could,
color black, and then you just put all the
and all the black ones. That
Anything
all the
that's
vertical
black
ones at
would
once.
follow
You're right.
that.
Yeah. That's
Yeah.
a good. That's a good. That's a good
just to make
comment.
it you know, just to save you a lot of
Yeah.
writing or copying and pasting.
I didn't think of that because when I was making it, I was thinking strictly in this, format of going from one to the next in a counterclockwise motion. Because when you're dealing with a lot of these, when I looked at that, some line is wrong. I wanted to make sure I knew which line was wrong because when you're looking at these a long code like this, it's hard to tell. That's why I put these comments here, the 4th gray and the 5th black, so I could tell which one was which. Because when you're doing so many at a time, if one line is wrong, you might not know which draw line function is the one that's messed up.
Right.
But that's a good idea, because that way I wouldn't have to keep going black, gray, black, gray, black, which is what I ended up doing. Yeah, that would have saved a lot of, a few lines of code there.
Another thing that you may want to consider doing, and again, this is for future reference, is animating that molecule. One of the nice things about Java is that, in an applet, you'll be able to introduce dynamic elements that way. So, for future reference, folks, we want to take something like this and, maybe show how it looks when you rotate it around the z-axis, for example. Not every molecule looks the same front, back, sideways, right? Bird's eye view. I mean, there's certain molecules that actually look different depending on how they're rotated. So, something for you to consider, okay?
Is that an object? And so, like, what is the animation?
It involves refreshing the applet.
Oh,
And then every time you refresh it, you get a slightly different composition. It's kind of like, Jerry, you know how people used to make cartoons? They used to have all the
cells.
paper?
Like
What are they called?
Cells.
Cells, yeah,
stop
exactly.
motion animation.
Right.
so it's like a
Think of the way an animated GIF is created. A bunch of static pictures,
Piece
but
together.
then, right, and then layered, and then you just instruct the browser to refresh, and then it shows different pictures, right? Okay.
Yeah.
Any other questions or comments? Okay, Daniel, thank you very much.
Yeah.
Thank you. I will.